Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have a to the power of a plus 2 to the power of a equals to 130, and here we solve this problem for the real values of a. So the very first step we are going to do is here first we make the prime factors of 8, and we know that the prime factors of 8 are 2 to the power of 3 and its whole power a, plus we have 2 to the power of a equals to 130. And now in the next step here we use the nice exponential law, and we know about this law. If we have a to the power of m to the power of n, and if we interchange these two exponents, it cannot be affected our final answer, so we just interchange these two exponents. And now we need to interchange these two exponents. According to this law, we write it as 2 to the power of a and its whole cubed plus 2 to the power of a equals to 130. And now here time to convert this exponential equation into the cubic form, so that we will just take here y equals to 2 to the power of a, and when we substitute y equals 2 to the power of a in the above equation, so it will be written as y cubed plus y equals to 130. So now this will becomes in cubic form. So here we rearrange the terms and we write it as y cubed plus y minus 130 equals to 0. So now here we have two methods to solve this cubic equation. So first we make the factors of this equation, or you know about the synthetic division, or you have another way to solve this cubic equation by using the synthetic division. But here we will easily make the factors of this equation. So here we focus on this minus 130 and we break this minus 130 in this form: y cubed plus y minus 125 minus 5 equals to 0. We just break this minus 130 in this form, and now we rewrite this equation as y cubed plus y minus, we have 125, we write it as 5 cubed minus 5 equals to 0. We know that 5 cubed equals to 125. And now in the next step we just combine the cubic term and the other term. So we have the cubic term is y cubed minus 5 cubed, and plus the other terms are y minus 5 equals to 0. So here we just use the cubic formula in the first factor in order to solve this equation. So we know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So this is our cubic formula, and if you focus here, we have the value of a is y and the value of b is 5 only. And now we substitute these two values of a and b in this formula to the right hand side, and it will be written as y minus 5 times of, here you have a square, so our a is y square plus ab, and our a is y and b is 5, and plus b square, so b is 5 square, and plus here we have y minus 5, and this whole equals to 0. So here we just use the cubic formula and we write this in this form. So here you focus on both of these terms, and you see here we have y minus 5 be the common factor, so that we take common here and we get the remaining terms are y square plus 5y plus 5 square becomes 25, and when we take y minus 5 common, and we get here plus 1 equals to 0. And now in the next step we rearrange the terms, and we have y minus 5 into y square plus 5y plus 25 plus 1 becomes 26, and this whole equals to 0. And after that we have two cases here. So our first case is we take y minus 5 equals to 0, and the second case is we take y square plus 5y plus 26 equals to 0. So in this case we have the value of y equals to 5. So this is the real value, and now we check is this quadratic equation has real root or not. So we check this by using the discriminant formula. So here first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 5, and c equals to 26. And now here we use the discriminant formula. You know about discriminant formula. It will be written as delta equals to b square minus 4 times of ac. So here we substitute the values of a, b and c here, and we get 5 square minus 4 times of a is 1 and c is 26. And here we need to simplify this equation, and you get here 25 minus 4 times of 26 becomes 104, and 25 minus 104 equals to minus 79. And you see here this is less than 0. So if our delta less than 0, it means that our quadratic equation has no real root. So this quadratic equation has no real roots, so that we rejected this case, and we will just proceed here this case only. And in this case we have y equals to 5. So here we back substitute the value of y, and we substitute our y equals to 2 to the power of a. So we back substitute this value of y, and we have because our y equals to 2 to the power of a, it will be written as 2 to the power of a equals to 5. And now we solve this problem for the values of a. So here we take the natural log on both of the sides of this equation, and it will be written as log of 2 to the power of a equals to log of 5. So here we use the nice property of log, and we move this exponent in the front of this log, and it will be written as a times of log 2 equals to log 5. Because we find the value of a, so we move this log 2 to the right hand side, and it will be written as log of 5 divided by log of 2. And here we use the calculator, or we just use the logarithmic table in order to find the value of this expression. So we know that the value of log 5 is equals to 0.699, and the value of log 2 is 0.301. So when we subtract these, when we divide these two values, then we easily get the approximate value of a is 2.32. So this is the final real value of the given question. And now here we check this value, is this value satisfied our given question statement or not. So our given question statement is a to the power of a plus 2 to the power of a equals to 130, and we substitute this value of a on the left hand side, and it will be written as 8 to the power of 2.32 plus 2 to the power of 2.32 equals to 130. We check is this equals to 130 or not. So when you take the power of 8 is 2.32, it will be written as it is equals to 125.01, and this is equals to 5.00, and we check is this equals to 130 or not. So when you add these two values, it will be equals to 130 equals to 130. So this shows that a equals to 2.32 satisfied the given question statement, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.